Astronomers have identified the most massive stellar black hole yet discovered in the Milky Way galaxy. This black hole was spotted in data from the European Space Agency's Gaia mission, because it imposes an odd, wobbling motion on the companion star orbiting it. The stellar mass black hole, designated Gaia, BH3. Data from the European Southern Observatory's Very Large Telescope, and other ground-based observatories, were used to verify the mass of the black hole, putting it at an impressive 33 times that of the Sun. The previous most massive black hole of this class found in the Milky Way was a black hole in an X-ray binary in the Cygnus constellation, whose mass is estimated to be around 20 times that of the Sun. The average stellar mass black hole in the Milky Way is about 10 times heftier than the Sun. Gaia, BH3 is located just 2,000 light-years from Earth, making it the second closest black hole to our planet ever discovered. The closest black hole to Earth is Gaia, BH1, which is 1,560 light-years away. Gaia, BH1 has a mass around 9.6 times that of the Sun, making it considerably smaller than this newly discovered black hole. It was discovered when astronomers analyzing data from the European Space Agency's Gaia mission spotted a strange wobbling motion in a star located in the constellation of Aquila. It turned out this jiggling was being caused by the star orbiting a black hole, Gaia BH3. No one was expecting to find a high-mass black hole lurking nearby. Undetected so far, study author Pasquale Panuzzo, an astronomer at the Observatoire de Paris, part of France's National Center for Scientific Research, said in a statement, "This is the kind of discovery you make once in your research life." Seabrook added that Gaia BH3 is an important clue to this population, because it is the most massive stellar black hole found in our galaxy. Of course, Gaia, BH3 is a small fry compared to the supermassive black hole that dominates the heart of the Milky Way, Sagittarius A, which has a mass 4.2 million times that of the Sun. Supermassive black holes like Sagittarius A aren't created by the deaths of massive stars but rather by mergers of progressively larger and larger black holes. As a result, black holes don't emit or reflect light, meaning they can only be seen when they are surrounded by material that they gradually feed on. Sometimes, this means a black hole in a binary system pulling material from a companion star, which forms a disk of gas and dust around it. The tremendous gravitational influence of black holes generates intense tidal forces in this surrounding matter, causing it to glow brightly with material that is destroyed and consumed, also emitting X-rays. Additionally, the material the black hole doesn't feast on can be channeled to its poles and blasted out as near-light speed jets, which are accompanied by the emission of light. The star that orbits Gaia BH3 was hoped to give clues as to the star that died so that the black hole could be born, as binary stars often have similar compositions. Data from the Ultraviolet and Visual Echelle spectrograph instrument on the European Southern Observatory's Very Large Telescope found that the companion star was very metal-poor, meaning the black hole parent star likely was as well. Metal-poor stars, predominantly composed of hydrogen and helium with minimal heavier elements, are believed to retain more mass throughout their lifetimes, potentially leaving behind enough material to form more massive black holes upon their demise. However, direct evidence connecting metal-poor stars to the formation of high-mass black holes has been elusive until now. Thanks to the sensitivity of Gaia, the Black Hole Task Force was also able to put constraints on the mass of Gaia, BH3, finding it to possess 33 solar masses. Gaia, BH3 is the very first black hole for which we could measure the mass so accurately, said Sevi Mazet, a scientist and Gaia collaboration member at Tel Aviv University. At 30 times that of our Sun, the object's mass is typical of the estimates we have for the masses of the very distant black holes observed by gravitational wave experiments. Gaia's measurements provide the first undisputable proof that, stellar mass, black holes this heavy do exist. However, the Gaia, BH3 system is bound to be of great interest to scientists for more than just its proximity to Earth and the mass of its black hole. This research was presented in a paper entitled, Discovery of a Dormant 33 Solar Mass Black Hole in Pre-Release Gaia Astrometry. The paper, by P. Panuzzo et al., is authored by the Gaia collaboration, which involves over 300 authors from around the world, including Austria, Belgium, Czechia, Finland, France, Germany, Italy, Netherlands, Poland, Portugal, Spain, Sweden, Switzerland, United Kingdom, Chile, and Australia. The team's research was published today, April 16, in the journal Astronomy and Astrophysics. There is much more data being gathered on this black hole and its star, but this will not be released in its entirety until 2025. We took the exceptional step of publishing this paper based on preliminary data ahead of the forthcoming Gaia release because of the unique nature of the discovery, paper co-author Elisabetta Caffau, a researcher at CNRS Observatoire de Paris, said in the statement. The European Southern Observatory enables scientists worldwide to discover the secrets of the universe for the benefit of all. They design, build and operate world-class observatories on the ground, which astronomers use to tackle exciting questions and spread the fascination of astronomy, and promote international collaboration for astronomy. Established as an intergovernmental organization in 1962, today ESO is supported by 16 member states: Austria, Belgium, Czechia, Denmark, France, Finland, Germany, Ireland, Italy, the Netherlands, Poland, Portugal, Spain, Sweden, Switzerland, and the United Kingdom, along with the host state of Chile and with Australia as a strategic partner. ESO's headquarters and its visitor center and planetarium, the ESO Supernova, are located close to Munich in Germany, while the Chilean Atacama Desert, a marvelous place with unique conditions to observe the sky, hosts our telescopes. ESO operates 3 observing sites: La Silla, Paranal, and Chijnantar. At Paranal, ESO operates the Very Large Telescope and its Very Large Telescope Interferometer, as well as survey telescopes such as Vista. Also at Paranal, ESO will host and operate the Cherenkov Telescope Array South, the world's largest and most sensitive gamma-ray observatory. Together with international partners, ESO operates ALMA on Chijnantar, a facility that observes the skies in the millimeter and sub-millimeter range. At Cerro Armazones, near Paranal, we are building the world's biggest eye on the sky, ESO's extremely large telescope. From our offices in Santiago, Chile, we support our operations in the country and engage with Chilean partners and society. Gaia's next data release is expected to contain many more, which should help us to see more of the matrix and to understand how dormant stellar black holes form.